Hello and welcome to another ScienceMan digital lesson. Today we're going to talk about the law of reflection. And we'll start by looking in a water environment, and here on the left side of my screen I've got what looks like a typical ripple tank, and I've got a wave source generator, a flat one, and it's got some flat waves going from left to right. So what I'm going to do is have a little bit of fun and drag a plane reflector into the water pool, and then I'm just going to spin it a bit, rotate it, and then extend the barrier a bit. And what we'll do is we'll let those waves hit that barrier and see what the effect is on the waves, because when they're uninterrupted they move in a straight line, but when they hit this barrier something's going to happen to them. And most people know that when a waveform hits a barrier, it reflects. But exactly how is this going to reflect? Well, while this is reflecting, let's bring in a couple of markers. So I'm just going to mark the initial movement of the wave, and it was in this plane, so from left to right, and it looks like the pattern of our waves is forming, the reflected waves is forming, and they seem to be traveling straight up. Straight up. So there's our reflected waves. Let's drag a marker in and make note of the plane of movement of these reflected rays. So we'll just move our marker into position right there. Just like that. So our waves are reflecting up, so they're traveling in the upward direction. Now, if we're going to analyze this as per what is the angle of incidence and the angle of reflection, what we need to do is draw a normal line, and that's a line that's perpendicular to the reflective surface. So what we'll do is put our normal line right there, and that's about 90 degrees right there to our point of reflection. We'll just move our whole line right there, and it looks like what we've got, if we compare this angle right here to this angle right here, we've got very similar angles. And basically that's the law of reflection. The angle of incidence is always equal to the angle of reflection. Now, these are water waves, but the same thing applies to light as well, because light has wave-like properties. So if we just move over to this environment to the right, and we have a beam of light, we can confirm this by taking a plane mirror and putting this in front of our beam of light, and then we'll just rotate this a bit, and again at a angle that's similar to our water situation. Just adjust it slightly. There we go. And then what we'll do is we're just going to double click on this mirror, and we're going to ask it to show the normal line. So if we move this so that we've got our mirror so that the light ray is striking right at the point of where the normal line is, we've got, it seems like, another confirmation of the law of reflection. And it doesn't really matter what angle we put our mirror at. Notice if we change the position of our mirror, and again making sure our normal line is right at the point of reflection, we get angles on the incident side and the reflected side that are very close, that are the same. So again, that's the law of reflection. The incident angle is equal to the reflected angle. Thanks for viewing this digital lesson. Again, Yenka is used to make these digital lessons, or some of them, and you can try some of this stuff yourself by going to yenka.com, downloading Yenka for free, and giving it a try. Thanks again.